Namaskaram, Namaskaram everyone. My name is Akshay. In this video, I am going to cover indeterminate forms, L'Hopital rule, and various methods to solve indeterminate forms. Okay. Along with this, I am also going to cover some important questions asked from various examinations like JEE and IIT JAM and GATE examinations. First, we discuss what are indeterminate forms. Okay, indeterminate forms occur when the limit of an expression cannot be determined simply by substituting the limit value into the function. What is the meaning of this? See, let's discuss one example. Limit x tends to 1, x square plus 2x plus 1. Okay, if you observe here, this is the function. Okay, which type of function it is? Second degree polynomial. Okay, that means it is a quadratic. Okay, quadratic function. Okay, it is a polynomial. Simply we call this as a polynomial function, right? It is a polynomial function. Okay, now first step is whatever the limit is given. Okay, substitute in the given function. In place of x, I will replace 1 here. I will get 1 square plus 2 times of 1 plus 1, that is equal to, if you simplify here, we get 4. Okay, 4 is the limit value for this function. Okay, 4 is the limit value for this function. Okay, for polynomial function, given polynomial function. Okay, this is the one example. See, by substituting x value directly, we obtain a value, limit value. There are certain functions like limit x tends to 1, x square minus 1 by x minus 1. Okay, there are certain functions like this. Okay, if you observe here, in place of x, if I will replace 1, okay, see which type of function we call this as. See, if you observe here, numerator is a polynomial, and denominator also a polynomial. Okay, polynomial by polynomial is there. It is a rational function. This function we call as rational function. Yes or no? Okay, now we substitute in place of x1. I will get 1 square minus 1 by 1 minus 1. 1 minus 1 is nothing but 0. By 1 minus 1, nothing but 0. See, we obtained 0 by 0. Okay, like we cannot cancel this both. Okay, and we cannot solve this one further also. Okay, see, when this type of situations are arrived, okay, this form we call as indeterminate form. Okay, 0 by 0 is an indeterminate form. We know that, see, denominator should be not equal to 1, then only this function is defined, otherwise the function is not defined, right? Here there is no restriction. If we want to find the approximate value, limit is nothing but approximate. Okay, limit is nothing but we finding the approximate functional value. Okay, approximate functional value. What is functional value? First of all, see, I'm given a one function x plus 1, for example. Okay, someone will ask what is the value of this function at x equal to 1. Okay, what is the value of this function at x equal to 1? Okay, in place of 1 I will replace 1. I will get 1 plus 1, that is equal to 2. This is also called as y value. Okay, this one is x value. Okay, by substituting this x value in the given function, we obtain a y value. Is it clear? Okay, similarly, f of x equal to x square minus 1 by x minus 1. If I will consider this value, this function, if I will substitute in place of x 1, okay, what happens? We get 0 by 0, 0 by 0. Okay, if denominator, if you get denominator is 0, okay, then this function is not defined. Okay, we cannot obtain the functional value at x equal to 1. Okay, instead of finding at x equal to 1, we approximately finding by using the limit concept. Okay, this is the form we get 0 by 0. Okay, further by using various methods like L'Hopital rule, factorization, okay, some expansions. Okay, there are various methods, okay, to simplify indeterminate forms. Okay, let's discuss one by one. Now there are common forms, okay, some common indeterminate forms. One is 0 by 0, okay, another one is infinity by infinity. These are the most important forms, okay, 0 by 0 form and infinity over infinity form. These are the two most important indeterminate forms, but other included, there are some other indeterminate forms also there. One is 0 into infinity, infinity minus infinity, 1 raised to the power of infinity, 0 raised to the power of 0, and infinity raised to the power of 0. Okay, these forms also called as indeterminate forms. Okay, these forms also we call as indeterminate forms only. Now let's discuss various methods to solve these indeterminate forms. Okay, first, for 0 by 0, 0 by 0 and infinity by infinity forms. Okay, to solve these two indeterminate forms, first method, okay, the method one is L'Hopital rule. Okay, most powerful method, L'Hopital rule. Okay, and second method is, if like some questions, okay, by applying L'Hopital, after applying L'Hopital rule also, some question become more complex. Okay, in that time we use second method, that is expansions. Okay, there are so various expansions like sine x, cos x expansions, okay, exponential of x, okay, and log of 1 plus x expansion, and 1 by 1 minus x expansion, etc. Okay, we taking help of these uh, functions expansions, okay, to simplify given limit problems. Okay, next, third one is factorization. Okay, factorization method, we use factorization method. Okay, and along with this we use, okay, along with these methods we going to use some standard limits like sine of something by something. What is this something? Okay, if you get, see, if you encounter with such type of thing, okay, sine of something by something, okay, if this something, whatever the thing is there, something is there, okay, if you apply the limit, if it is this value becomes 0. If this value becomes this something value becomes 0, if you are applying limit, whatever the limit is given here, okay, maybe it given any limit x tends to a for example something in whatever, okay, limit I will take generally, okay, for example instead I will take it limit x tends to a. Okay, in place of something, if I will replace this x value here, okay, it value gives us 0. Okay, here also it gives 0. Okay, whenever if you encounter with this such type of format, this value always equal to 1. Okay, this value is always equal to 1. Okay, and also this is same as sine inverse something by something here. Okay, instead of writing something I use some box type box, like box is nothing but indicates something. Okay, it is same for tan something by something. Okay, it is same for tan inverse something by something. Okay, if you encounter with any of these forms, you can replace this entire limit with 1. Okay, this is the thing. Okay, is this clear? Okay, and one more thing, 0 by 0 and infinity by infinity forms. Okay, we use L'Hopital rule. Okay, we use L'Hopital rule, and these remaining whatever the methods are there, method 2, method 3 and method 4, we can use these methods for commonly we use these 3 methods for all the indeterminate forms. Okay, depends on the question. Okay, depends on the question, we use all these 3 methods to simplify indeterminate forms. Okay, 0 by 0 and infinity by infinity, and these except 1 power of infinity, we have another method to simplify. We cannot simplify by using L'Hopital rule this form 1 raised to power of infinity form. There is a special form is there. Okay, 1 raised to power of infinity for 0 raised to power of 0, infinity raised to power of 0. Okay, to simplify these indeterminate forms, we have a separate method. Okay, I will explain later. For these two, 0 into infinity and infinity minus infinity forms, okay, we need to convert these two forms into 0 by any of these forms, 0 by 0 or infinity by infinity. Okay, if you want to simplify 0 into infinity form or infinity minus infinity form, okay, we need to convert these forms in the form of like 0 by 0 and infinity by infinity, then further apply any of these methods. Okay, first preference L'Hopital rule. Okay, if it is works, it's fine. It does not works, then go with any of these 3 methods. Okay, method L'Hopital rule. Okay, if the given limit is in the form of like this, limit x is approaching to a f of x by g of x. Okay, if you substitute a value in the numerator function, it is approaching to 0 by, okay, denominator function also is also approaching to 0 or approaching to infinity by approaching to infinity. If any of these forms, okay, then we use L'Hopital rule. Okay, first step is, if you confirm with these forms, indeterminate forms, then first step is differentiate numerator function, okay, and differentiate denominator functions separately. Okay, first differentiate numerator function and then differentiate denominator function separately. Okay, in this rule we're not going to use quotient rule. Okay, don't apply quotient rule here. Okay, differentiate numerator function separately and differentiate denominator function separately. Then we get this form. Okay, here the condition is denominator should be not equal to 0. Okay, it should not be equal to 0, or like this should see this form again not becomes like this 0 by 0 approaching to 0 by 0 or infinity by infinity. Okay, if you get any finite value or 0 or infinity, okay, instead of getting these forms, okay, instead of getting these forms, if you get 0 or any finite value is fine. Okay, if you get again 0 by 0 or infinity by infinity, again you need to continue the process. That means again you differentiate numerator separately, you get double derivative, and denominator also differentiate again. Okay, until this form should be vanished. Okay, this is the process. You continue like this. If you get again and again these forms, you should continue this process again. Let's discuss 1 raised to power of infinity form. What is 1 raised to power of infinity form? Okay, if the given limit is in a form of like this, limit extends to a f of x whole raised to power of g of x. Okay, if you apply the limit value here, limit here, okay, limit, if you apply the x value, okay, limit, we get this limit value, this f of x, okay, this value is approaching to 1 whole raised to power of, if you apply this limit to g of x, this value is approaching to infinity. Okay, this written as simply 1 raised to power of infinity. Okay, these forms we call as 1 raised to power of infinity form, indeterminate form. Okay, the method is simple. Okay, take log on both sides and simplify further. Okay, then finally you will get L value. This is the process method one. Okay, by explaining the questions, okay, I'm going to solve some examples. Okay, questions. In that I will discuss detailedly. Okay, the method one is to simplify this, to simplify 1 raised to power of infinity. The method one is take log on both side. Okay, simplify further. Okay, and method 2 is shortcut. This is the shortcut method. Whenever if you get such type of indeterminate form, 1 raised to power of infinity form, okay, you can apply directly this shortcut. Okay, what is shortcut here? The value, limit value, that is equal to e raised to power of limit x tends to a f of x minus 1 into g of x. Okay, this is the shortcut. L is equal to e raised to the power of limit x tends to a f of x minus 1 g of x. Okay, method 1 is the normal method. Okay, this is the shortcut method. Okay, there are some other forms like 0 raised to power of 0. Okay, we apply method 1 for remaining indeterminate forms. This shortcut is applicable only for 1 raised to power of infinity. Remember this. Okay, this shortcut method is only applicable to 1 raised to power of infinity. Okay, for other remaining indeterminate forms, we can use this method one. Okay, this is the question. Limit x tends to 0 in the numerator function is given x cos x minus sin x. In the denominator function is given x square sin x. Okay, first substitute this given limit here in the given functions in the numerator and denominator functions both. If you substitute here, we get numerator function also approaching to 0, denominator function also approaching to 0 only. We get 0 by 0 form. Okay, if you get 0 by 0 form, we can apply first. Our first method is what? L'Hopital rule. Okay, first if you observe here, numerator function is fine. Here x is there, cos x is there. Differentiate numerator function separately, differentiate denominator function separately. Okay, if you differentiate numerator function is okay, x cos x. Okay, you can apply product rule. In the denominator also we can apply product rule, x square sin x. But if you observe here, this is in the denominator x square polynomial of second degree, polynomial of second degree. Okay, and along with sin x, trigonometry. Okay, whenever such type of pattern if you observe, okay, first try to simplify instead of applying directly L'Hopital rule. Okay, if you suppose, if for example, if we can apply directly L'Hopital rule here, the thing is, again next step also, because of here degrees x square, polynomial degrees, polynomial of second degree, if you differentiate, okay, you get product rule, you need to apply product rule. Okay, again if you substitute x value, you get 0 by 0 form. Okay, instead of doing like that, first we simplify this. Okay, because we know that limit x tends to, here 0 is there, 0. Okay, sine of something by something is there. Okay, if this something is approaching to 0, okay, this something becomes 0, this value equal to 1, right? If I will rewrite like this one, here see, here x is there. Okay, that means if I will convert denominator also, if I will divide some x value denominator, and if I will multiply one more x and numerator, okay, this becomes x cube. Okay, this becomes x cube. Now if you apply the limit value, limit here, okay, this value becomes 1. Okay, then further this limit x tends to 0, x cos x minus sin x by x cube you get. Okay, because x value becomes 0. Okay, this value also 0, then something both is approaching to 0, both something is giving 0, then we can replace this. In place of this I will replace it 1. Okay, here I replaced 1. Okay, if you want we can further also simplify this. Okay, otherwise if you apply again you get 0 by 0 only. Now we can apply L'Hopital rule directly. What is L'Hopital rule? Differentiate numerator 1, differentiate numerator. What we get here? Product rule, x differentiation 1, cos x as it is, plus x as it is, cos x differentiation minus sin x, minus sin x differentiation cos x by 3x square. Okay, this becomes, this cos x and minus cos x get cancels, then limit x tends to 0, you get minus x sin x by 3x square. Okay, again this x and one more x get cancels here. Okay, this equal to, see here, 1 is the minus 1 by 3. Okay, they both are constant. I will keep this outside, minus 1 by 3. Then limit x tends to 0, sin x by x. Again, we know that this value equal to 1. This value equal to 1. Minus 1 by 3 into 1 is minus 1 by 3. Okay, this is the value we get. Okay, like this we can apply L'Hopital rule by just modifying some values. So like modifying some functions. Okay, yes, here numerator, it involves a integration. Okay, the denominator is a normal product of two functions. First, if you apply the first, our step is substitute this x value in the given functions. If you substitute here, okay, this becomes 0. In place of x, if you replace 0, 0, okay, it is something dt. We know that if upper limit and lower limit both values become same, if both the limit values same, this value equal to 0 only. Okay, upper limit and lower limit, indefinite integration, if upper limit and lower limit both are same, this integration value equal to 0. That means this function is approaching to 0 divided by, in place of x, if you substitute here 0, denominator function 0, is sin 0 also 0. Okay, this is also approaching to 0 only. This again gives 0 by 0 form. Okay, then differentiate numerator and denominator. Okay, how to differentiate this? So it is a definite integration, and one more thing, it is not with respect to x, it is with respect to t. How to differentiate, how to deal with this, such type of questions? Okay, we need to use Leibniz rule. What is Leibniz rule? See, whenever if you deal with such type of function, okay, lower limit in terms of x, okay, numerator in terms of x, it is f of t dt, it is given like this. Okay, what you have to do now, substitute this upper limit in the place of t. Okay, you get f of xi of x, and then differentiate numerator, sorry, differentiate this upper limit xi dash of x minus, again substitute this lower limit in place of t, f of pi of x, again differentiate pi of x, pi dash of x we get. This rule we call as Leibniz rule. Okay, this we going to use here. Okay, here we going to use, see, this is integration 0 to x square cos of t square dt. Okay, this is the rule. Okay, because we applying L'Hopital rule here, I am differentiating numerator and I am differentiating denominator separately. Okay, by differentiating this one, okay, by differentiating the d by dx, okay, differentiating, here I am differentiating this. Okay, apply here, in place of t replace x square, I will get cos of x square whole square. Okay, again x square differentiation 2x, here lower limit is 0. Okay, in place of t you replace 0, and differentiation of 0, 0 is a constant, differentiation of 0 is 0 only. Okay, that's why this complete term vanishes. Okay, no need to write. Simplify this, you get this is 2x cos of x raised to the power of 4. Okay, numerator we get like this, and limit x tends to 0, numerator we get 2 is a constant, keep outside, x cos of x raised to power 4, and differentiate denominator function, x differentiation is 1. Okay, sin x is as it is, plus x is as it is, sin x differentiation cos x. Okay, then if you observe that in place of x, if you substitute again in the place of x, if you substitute 0, it becomes again 0. Okay, this complete numerator term becomes 0. Okay, because 0 into something whatever we get here, okay, that value becomes 0. Here if you substitute here also cos 0 value is what, 1. 0 into 1, 0 only. The denominator, if you substitute sin 0, 0. Okay, here again here x is there, in place of x if you substitute 0. Okay, this becomes 0, 0 plus 0, 0. That means this again we get 0 by 0 form only. Again we get 0 by 0 form. That means we need to differentiate again this. Okay, to keep 2 as it is, differentiate numerator again. Okay, apply the product rule, x differentiation is 1, cos of x raised to power 4 plus x as it is, cos of x raised to power of differentiation minus sin x raised to power 4, again x raised to power 4 differentiation 4x cube by, okay, denominator sin x differentiation cos x, x cos x differentiation is 1, cos x plus x is as it is, cos x differentiation minus sin x. Okay, now if you substitute in place of x 0, this value gives 1. Okay, this because of x here. Okay, this complete term becomes 0 by cos x, cos 0 1, cos 0 value 1. Okay, 1 plus 1 2, because of here x is there, 0 into this becomes 0. Okay, 2 plus 0 2 only, again 2 get cancelled, we get 1. This is our final limit x is tends to 0, cos x whole raised to power 1 by x square is given, and 4 options are given. First substitute is x value here, this function is approaching to 1. Okay, cos 0 value 1, this is approaching to 1, and in place of x if you substitute 0, 1 by 0 infinity, that means this function is approaching to infinity. That means it is in the form of in 1 raised to power of infinity. Okay, if you get in the form of like this 1 raised to power of infinity, okay, direct shortcut I am given, e raised to power of limit, here limit is x tends to 0, limit x tends to 0, f of x minus 1 into g of x. It is in the form of like this, f of x whole raised to power of g of x, right? Compare here, limit x tends to 0, here f of x is cos x minus 1 into g of x is x square. Okay, we get like this. If you substitute 0, cos 0, cos 0 value 1, 1 minus 1, 0 by 0. That means this limit value, again it is in the form of 0 by 0 form. Okay, if you get again it is in the form 0 by 0 means we can apply L'Hopital rule, e raised to power of limit x tends to 0, differentiate numerator, cos x differential minus sin x, minus 1 is a constant, okay, 0, x square differentiation 2x. Okay, that is equal to e raised to power of minus 1 by 2 is constant, keep outside, limit x tends to 0, sin x by x. We know that this value 1. Okay, this finally we get e raised to power of minus 1 by 2 is the correct answer. B is the correct option. Okay, here B is the correct option for this question. Okay, let's discuss these questions. The first question, if you apply the infinity, okay, see this becomes infinity by infinity. Here also we get infinity. Okay, first, before applying limit here, if you observe that this is the second degree polynomial, it is also second degree polynomial, that means quadratic function. Okay, this is the quadratic function, it is also quadratic function. The both are polynomial function with same degree. Okay, whenever we get such type of question number one, it is first one, just simplify, just take numerator highest degree. Okay, take common x square. Okay, we get here 1. Okay, if you take highest degree common, we get here 1 plus pi by x plus 3 by x square. We get like this. By here also x square is a common, we get 1 plus we get 1 by x plus 2 by x square. We get like this. Now this get cancelled. Okay, whole raised to power of x. Now if you apply the limit, here, okay, pi by infinity, we know that 1 by infinity, this value equal to 0. That means pi by infinity, this value equal to 0. This value also becomes 0. This is 0. This is 0. Finally, we left with 1 by 1, that is 1. Whole raised to power of, in place of x, replace infinity, we get infinity. That means we get 1 raised to power of infinity form. Okay, this is in the form of 1 raised to power of infinity. Okay, then use the shortcut e raised to power of limit. What is the limit here? X tends to infinity. Okay, f of x, see this is in a form like this, f of x whole raised to power of g of x, right? Okay, here f of x is x square plus 5x plus 3 by x square plus x plus 2 minus 1 into g of x is x. Now take LCM, get e raised to power of limit x tends to infinity, x square plus 5x plus 3 minus x square minus x minus 2 by x square plus x plus 2 into x. We get like this. And here x square and minus x square get cancelled. And e raised to power of limit x tends to infinity, 5x and a minus x is 4x and plus 3 minus 2 is plus 1. Okay, by x square plus x plus 2 into x. Okay, we can multiply this x inside. Okay, what we get? E raised to power of limit x tends to infinity, get 4x square plus x by x square plus x plus 2. Okay, e raised to power of limit x tends to infinity, the degrees are same, take x square common, we get here 4 plus 1 by x by x square common, here also we get 1 plus 1 by x plus 2 by x square. Again if you apply the limit value, this becomes 0, this becomes 0, this becomes 0, this both get cancels, we get finally e raised to power of 4. Okay, this is our required answer. Okay, we done this question. Now we discuss second one. Okay, if you apply in place of x 0, we get this is lower limit and upper limit both become zeros. Then this complete numerator value is approaching to 0, denominator also approaching to 0, that means it is in the form of 0 by 0 form. It is in the 0 by 0 form. Then differentiate numerator and denominator, differentiate numerator, okay, denominator separately. Okay, applying L'Hopital rule here. Limit x tends to 0. We know that in place of t, replace upper limit sine root of x square, okay, into x square. Again, x square differentiation is 2x by, okay. In the denominator, see, a lower limit is 0. Okay, in place of t, if you replace, we get sine 0. Again, 0 differentiation also 0. That means we get 0 only. Okay, no need to write that term. Okay, this term we get 0 only, no need to write. Again, x cube differentiation in the denominator, 3x square. Okay, 1x get cancelled. Okay, limit x is approaching to 0. Okay, sine square root of x square, nothing but mod x, okay, by 3x. Okay, 3 is take outside, limit is approaching to x tends to 0, sine mod x. See, mod, if you apply this x value here, okay, this is approaching to 0. This value gives us, this is something mod x, this is giving to, this gives us 0. Okay, this mod x can I return as nothing but x only, okay, by x. Simply it can be written as x only. Okay, why? Because see, the sin x graph, okay, sin x graph is what it is, it is a 0. Okay, if you're applying the limit here, 0, the sine mod x graph is above the x-axis. The sine mod x graph is above the axis. It is graph is like this. Something we get like this. Okay, sine mod x graph is, we get something like this. Okay, we are applying 0 here. Okay, if you consider left side or right side, the graph is above the x-axis only. The graph is above the x-axis, sine mod x is positive. Okay, it's a positive. Okay, instead of writing mod x, I replace it with x. Okay, is it clear? Now, if you observe that this is x is approaching to 0. Okay, this value becomes what? 1. Okay, 1 by 3 into 1 gives us 1 by 3. This is our required solution for the second one. Okay, next question is, limit x is approaching to infinity, 1 plus a by x whole raised to the power of x is there. In place of x, if you replace infinity, a by infinity gives us 0. Okay, this function becomes infinity. That means it is in the form of 1 raised to the power of infinity form. Okay, if it is 1 raised to the power of infinity, we have a direct shortcut, e raised to the power of limit. What is the limit here? X tends to infinity. F of x, here f of x is 1 plus a by x minus 1, g of x is x. Okay, 1 minus 1 get cancels, e raised to the power of limit x tends to infinity, a by x into x, again xx get cancelled, that is equal to e raised to the power of limit x tends to infinity a is a constant, the limit value gives us a only, e raised to the power of a. Okay, this is our required answer for this question. Okay, and finally this is somewhat interesting question. Okay, see, instead of using like previous methods, I'm going to give one shortcut trick, n factorial. What is n factorial? What is n factorial? Product of first n natural numbers. Okay, 1 into 2 into 3 into 4 into and so on, n minus 1 into n. Okay, this product gives us n factorial. Okay, here the one we have to remember one thing here. Whenever if you see n factorial or any factorial, okay, n factorial something whatever is given, factorial term related something given, okay, n factorial is given, it can be written as n raised to power of n by e raised to power of n. Okay, this is the shortcut trick. You remember it can be written as n by e whole raised to power of n also. Okay, this is the shortcut trick you can use directly. Okay, here also limit extends to infinity. In place of n factorial, I'm going to use this n by e whole raised to power of n. Again, the power 1 by n is there, 1 by n by n. Okay, this n and get cancels, powers get cancels. That is equal to limit x tends to infinity n by e, okay, into n. It can be written like this. Okay, n, this n also get cancels. Finally we get limit x tends to infinity 1 by e. 1 by is a constant. If you apply the limit also we get 1 by e only. Okay, this is the solution, this is the value we get. It can be written like this also, raised to power of -1. Okay, this